This conference will now be recorded.
Okay, so today we'll just discuss the basics of data warehouse. Okay, I mean what data warehouse is, why do we use data warehouse, and how do we create a data warehouse? If data warehouse is created, how do we store our data into those data warehousing disk? Okay, so we'll just cover up the basics so that you are aware of the terms which are used into data warehouse. Okay, we are not going into detail for this data warehousing as discussed earlier because this is itself a very big topic. Okay, which should be covered into a probably separate sessions, altogether a different training for this. Okay, but ETL perspective will cover up what things should we know about data warehouse. Okay, and how are we going to use it as an ETL developer or ETL tester or Abinitio developer. Okay, so we'll start. Okay, or are we going to wait for some more candidates? Raghu, you there?
Sure.
Yeah, can we start or should we wait for
Yeah,
1 or 2 more minutes?
Yeah, please go ahead.
Okay, perfect. Yeah. So what happens into our projects or live project wherever you are working in, if someone is working into any of the ETL tools or any of the data warehousing projects, right? So we used to get source files from different kind of source systems. Okay, so if we consider an example of any e-commerce website or any e-commerce projects, right? So what will happen? They will be having one website where they will be having all the products listed, right? And what kind of files they could receive if they are having a project? They could receive a file for inventory. What is the inventory that is left? They could receive a file for sales, what sales has been done for that particular day or that particular month, right? What are the best selling products or whatever products are selling, what is the unit cost, how many number of products have been sold, right? And they have their stores listed on their website, right? So whenever we are going to purchase any item, there will be 2 or 3 different vendors who are selling those items, right? And if you want to order from a particular vendor, you can select that, right? So they will be having their vendor list from which vendor they are selling, right? What is the discount that they are giving? All that kind of details will come into different kind of files. There could be a file for transaction, right? If you are using any gateway and if you are purchasing any item, you will be making some transaction. So there will be a different file altogether for transaction details. There will be a different file for your customers or users who are using that particular e-commerce website, right? So what we have to do whenever we are getting such kind of files, we have to load these files into some tables so that we can use it for our further analysis to take business decisions on time to time basis, right? So our e-commerce websites give us discounts on some particular time. They increase, sorry, just a minute. Okay, so they have to store this particular data into their data warehousing so that they can run any of the data mining application or data analytics application, and based on that they will be generating their reports which will be sent to business users, and for a particular time point of time they will analyze what sales have been done, which store has been performing good, right? Which store is performing bad at that particular time, or is there any store which is constantly performing good? And if there is a store that constantly performing bad, they might close that store which is not performing well, right? So that they can save their cost. So all this kind of analysis needs history data, right? We cannot take this decision based on a single day's file or a single month's file, right? We used to have some sort of span which should be decided by business users, like at least for taking business decision, I want this time frame data, right? Now suppose they have decided that they want 5 years of data for taking any such kind of decisions. So it becomes our responsibility to store the 5 years of data with complete history into some tables, right? And if we are going to use some random database or some smaller database, right, what we'll have to do, once our table space is full, once our database space is full, right, we'll have to install that particular database on some other disk, on some other server, and we'll have to plug it into all together in our application, right? So that increases my cost, that decreases my performance, right? So although I am paying higher amount, my performance is degrading. Okay, so later they came up with an concept of data warehouse where they take big size disk, they take clusters, they take data centers where they store their data. Okay, because if we are talking about any e-commerce website, let's say Amazon, into a day they will be having millions of transactions, they will be having billions of visit to their website or their application, right? They will have to store the complete information, right? And if you have seen, whenever you are using your smartphone and whenever you are searching for any product on any of the e-commerce platform, may it be Amazon, Myntra, Flipkart, or any other website, instantly you will be seeing those ads into your Facebook application, your Instagram application, or any of the social media application. We'll start seeing those ads, right? So these applications are also tracking our data, and as soon as they track your data, they see that you are showing interest into a particular product, they will start showing similar kind of products because they are also having their business strategy, right? So they will not only be showing you that product only on Amazon or Flipkart, rather they will be showing you what best price you can get on any other application, right? So all these kind of applications are running in the back end on your data. So data is the new money in today's world, right? Everybody wants data. Every application that you are using, every website that you are using, right, they will be tracking your data constantly, they will be storing your data, so that in future, whichever contracts do they have, suppose if Facebook has a contract with Amazon and Flipkart, right, and if you are searching your product on suppose Snapdeal, so they will capture this data that you are searching for this particular product on Snapdeal. They will start showing ads related to that product for Amazon and Flipkart, right? So all this kind of data we are storing into our data warehouse, right? All the transactions that you are doing on a particular e-commerce site. So I'm taking e-commerce site as an example. There could be different sector, may it be insurance, may it be banking, may it be retail sector, right? Different sectors. So they will be storing your data. Okay. And when we say data warehouse, we'll be having a big space. It could be a data center or a particular cluster into your data center. So what are cluster? Cluster is set of disks. Okay. So if we are talking about a particular disk, say a hard disk, right? We can install our database into a hard disk. The hard disk could be of 5 TB, 10 TB, 100 TB, but it is having a limited storage to it. Once this space is full, you will have to take additional disk. You will have to install your software, whatever database you are using. Suppose I am using Oracle, I'll have to install Oracle on that particular disk. I'll have to do a complete setup, and then I can start using that particular disk, right? Into data warehouse, we are already taking a complete cluster, and if required, we'll insert disk into that particular cluster, right? We'll install our, so into data warehouse also, we'll be using different kind of database DBMS systems only. It could be your Teradata, it could be your Hadoop, right? So there we'll be having techniques where we are installing our database on a name node. which will be my main node, and from there I'll be having connectivity to all my data nodes, right? And I'll start picking data from my data nodes for that matter. Okay, so definition wise, you will get multiple definitions of data warehouse on internet, right? I'll also be sharing few PDFs with you guys regarding data warehouse. So if you want to go deep into data warehouse, you can refer those PDFs. So there would be somewhere around 4 to 5 PDFs. Okay, but ETL perspective, I'm just telling you a background what data warehouse is, and if we are going through some terms into our training, you should not be confused. Okay, so these are some famous definitions given by, so W.H. Imon is known as the father of data warehousing. Okay, so what he says, data warehouse is a subject oriented, integrated, non-volatile and time variant collection of data, okay, which supports decision of management, right? Subject oriented, as in if you are talking about retail, if you are talking about e-commerce, so e-commerce, Amazon e-commerce will have their separate data warehouse, Flipkart e-commerce will be having their separate data warehouse. Similarly, banking will be having their separate data warehouse, right? So it differs subject to subject. Integrated, that means integrated, non-volatile, so your data is tightly coupled. Okay, it is not that you are loading your data into sales, you are loading into your data into inventory, right? These are two different subject areas into a data warehouse, and they are not connected together to derive some decision, right? So they should be tightly coupled, non-volatile. You should not lose your data in between the process, or it should not happen that you have loaded your data into your data warehouse and after 1 week or 1 month's time you are not able to find your data, right? So your data should not disappear. Time variant, as per the time, if there are changes into your data, right, you should be saving those changes, or you should be capturing those changes and storing it into your data warehouse so that you can further analyze those changes and take your business decisions, right? So in a pictorial form, if you'll see, we are having different data sources. It could be your flat files, it could be your Excel files, it could be your CSV files, some small tables, some web services as in if we are using Amazon e-commerce website, right? You are getting that data from your websites. So we are calling it web services. You are getting your data from distributed file system, say Hadoop, right? You're getting your data from some applications. So there could be heterogeneous data sources, right? So we'll bring that complete data into staging area so that we can perform some operation on it, right? Whether it is regarding removing duplicates, whether it is converting as per your target tables to store it into data warehouse, right? So we'll do it in all together into staging area. And if you are storing your data into a table which takes data from 2 or 3 different data sources, so in staging area we'll be performing some operation. It could be join, right? It could be any other operation that can be performed to transform your data, and then you are loading it into your warehouse. So what warehouse will contain? It will contain your data. It will contain data about data, like what kind of data it is, right? So data about data is known as metadata, right? So if you are receiving a file and some data into it, so the raw data we call as data, okay, and the information such as how many number of columns are into that file, what are the column names, what is the column sequence, what is the column data types, all that information is known as metadata. Okay, so we'll store this into data warehouse, and this data warehouse can further be distributed into data marts. Okay, so what is data mart? Data mart is small copy of warehouse, but it is for a particular subject, right? So suppose for Amazon I have a warehouse, data mart will be subject oriented, right? Into that retail also I'll be having different sectors, right? There could be a data mart for purchasing where I'll only be having data for purchasing, right? There could be a data mart for sales which will only contain the details about sales, right? There could be a data mart for inventory where I am just storing the information of my inventory. How much inventory has been sold, how much inventory is left, what next order should be placed, right? So if I have to take decision for a particular inventory, I'll go hit that particular data mart, not the complete data warehouse, right? And once we have distributed our data into particular subject area or data mart into a warehouse, I can run my reporting applications, my analytical applications, right? My data science applications, which will generate some reports so that we can send those reports to our business users, and based on that information they can take the decisions to improve their business, right? So in case of e-commerce, what happens whenever a festival arrives into India, may it be Diwali or Christmas, they know at this particular time customers will be going and buying clothes and electronic items, right? So if you look at that particular time, you will be having more discount. If you compare the discount today and if you compare the discount around Diwali time, there will be huge gap and difference, right? So how are they taking this decision? Not a person is sitting over there and entering discount per item, right? So they have complete information into their data warehouse, purchasing, sales, inventory, their dates. They will run their analytical application in which month which item is being sold more, right? So suppose if in month of May people are buying more room coolers and water coolers due to heat, they will increase the price of that particular item at this particular point of time, because they know that people are going to buy it anyhow, right? In month of say March or April, they will reduce the price, or in month of June they will reduce the price, right? Because they know at this point of time this item is not going to sell more, so let's reduce the price. If someone wants to purchase it, they will purchase it. At the month of October or November, they know this is Diwali, customer sentiments are buy electronic items, buy clothes, they will be stocking these items more into their stores, into their warehouses, right? So that they can fast deliver it. If an item is not being sold more, they will remove it from their stores, right? They will store it less. They will play with the prices, with the discounts. And if you'll see, for different customers, there are different discounts in terms of coupon codes. So a customer receives a coupon code, he will get additional 5 to 10% of discount, right? So how do they take these kind of decisions? For this, data becomes very important. Okay, and none of the company, may it be small or big, they do not want to lose their customer data. Okay, so every company now has their own data warehouse based on their requirement. Okay, so now we have seen what is the purpose of data warehouse and how are we going to use that data warehouse in form of staging area, data sources, target user, and data marts. Now we'll see if one has to store data into data warehouse, how do they do it, right? So we have data warehouse architects who decide which schema to use. Schema as in what? So we have discussed that we are getting data, we are going to store it in form of tables, but how those tables should be connected, what structure should be followed, right? That again depends on requirement. So we are having different kind of schemas available into data warehouse, but the most important are these two schemas, star schema and snowflake schema. Okay, before that we should know the terms fact tables and dimension tables. Okay, so fact tables are the tables in which we store transaction data or the data which cannot be changed further. Okay, so what it could be? It could be ID, it could be transaction amount, it could be transaction date, any statistical data that is not going to change, right? So now suppose if you are a customer, if you are a customer into a particular bank, you will open your account, right? Your account number is not going to change now. So I'll store that account number into a fact table, suppose account table, right? And regarding that account number, there will be a customer. That customer details I'll be saving into a dimension table. right? Customer can change their name, customers can change their contact details. So I'll be having a different dimension for contact. I would be having a different dimension for address. So all the details which are bound to change, I'll be storing it into dimension tables. The details which are not going to change, I'll store it into fact tables. Okay. So what star schema says, a fact table will be directly connected to all the dimensions, right? So if we'll see this picture, right, what's happening is there is a fact table, okay, and there are three different dimension tables. So into fact table, what I have done, I have three different dimensions. So all the dimension table are having their own primary keys. So store dimension is having store ID, store number, store province, and country. Similarly, product dimension is containing product ID, EN number, product name. Similarly, date dimension will be having its ID, date, which is the day, which is the day of month, which is the day of week, right? What is the quarter? All these details. And I'm connecting this fact table, okay, with all the dimension with the primary key foreign key relationship. So the primary key of store dimension becomes a foreign key into my fact table, so that I can establish a relationship between them. And whenever I want to fetch some data, I'll query this fact table based on these primary key foreign key relationships. I can fetch the data from the dimensions also. Okay, what Snowflake schema says, it is not mandatory that the fact table should be connected to all the dimension. So here my fact table is connected to date, store, and product. Product dimension is again connected to brand and product category. Store dimension is again connected to a geographical dimension. Date is again connected to three different dimension, probably day of week, date, month, and quarter, right? And all the details about this quarter I am not directly storing into this dimension, rather I have connected it with quarter dimension using primary key foreign key relationship. Okay, and when I query on this fact table, this dimension table, I'll take this ID again. We'll have to write some query where we are going to fetch data from quarter to dimension and dimension to this fact. So this, if we are having very huge data, we'll go for snowflakes, but that will again slow the process of our query, right? Because what we are doing, instead of joining two tables, now we are joining three tables, say, right? So it will take some time, but since data is huge, I do not want to overburden my tables. So that suppose if I'm writing a query directly to dimension and all the data is included over here, right, and the size is huge, so just querying this table will take a lot of time. Rather, if I had distributed its data into four tables now, and if I query it, it will take lesser amount of time. But whenever you are querying fact, and if you want to take data from this particular area, then it might take time. But since data is huge, we can go for Snowflake schema. So these decisions are taken by your database architects or data warehouse architects, data architects, information architects. There are different terms which schema they want to follow. Okay, so as an ETL developer, we should not be much worried about these structures, but we should aware of the terms. Okay, then what is data? So we have come across these terms. We have data sources, we have metadata, right? What we are deriving, we are creating some information and then we are storing it into data warehouse. So what we are storing into data warehouse, that becomes a information. What these guys do, that becomes your analytical data, right? So if we'll see the definitions, what is data? Data is composed of individual discrete facts that collect descriptive, quantitative, and qualitative value of business interest, right? So data, raw data, you are receiving into files, you are receiving into tables, right? So that contain discrete information, right? And we are not saying it an information because we have not distributed it. It is not yet meaningful until I take it into this staging area and transform it, right? So if I give a flat file to any of the user, and if I do not tell that user what information this file contains, it is just a garbage for that user, right? So we'll have to convert it into information. Now, when we are storing it into data warehousing, so what warehousing involves? It involves two kind of data. One would be operational data or transactional data, right? It will store, say, it will be events or transaction that are happening, right? If you're opening a account, it is a transaction. Account number is created, it is a transactional data. Now, if you are changing your address, it becomes a dimensional data or informational data. That is your information, address, your mobile number, right? So that becomes an informational data for me, which I have to store, right? Once I convert these raw files, if I have metadata, now I am able to impose that particular metadata on that raw file, and I can read that raw file in form of information, right? Now suppose I have a simple text file where I have three columns, column 1, column 2, column 3. If I have that file only, I do not know what kind of data it is. But if I get a metadata for that file, like first column is customer ID, type is decimal. Second column is customer name, type is string. Third column is customer address, type is string. Now, if I impose this metadata on this raw file or text file which I am receiving, now if I read this data, I know this is the customer name, this is the customer ID, this is the customer address. So I can link that complete information, and now that file became meaningful for me, right? Now it has become an information for me, right? Once we store this information into data warehouse, and if we are running some analytical applications, it becomes a knowledge for me, because based on this knowledge, based on this data, I am deriving some business decisions. So what we call it? We call it as a knowledge. I have knowledge, or I have analytical data based on which I can take my business decisions to improve my business. Clear? Any question until now? Anyone?
Does the schema kind of decide the kind of work that we do on a day-to-day basis? Like, does it? I mean, yeah, there are different forms of schema, the star schema, snowflake schema. So how much of an impact does that have on our daily work when it comes to Abinitio?
That won't have much impact. As in, whenever you are working into a project, right? Your data warehouse architects or your information architects would have already analyzed what kind of data they will be getting, how many number of fact tables do they want, how many number of dimension tables do they want, right? And how these tables are interconnected. Based on that, they would have already taken the decision that we are going to follow, say, star schema or snowflake schema, and that decision will come best into best for your process, right? So that they know, suppose they know that they are not going to receive that much of data, and they want a faster analysis or faster querying techniques, they will go for star schema. They know if they're having huge number of data, time is not the constraint for them. Whether they are performing their query in 5 minutes or 50 minutes, that does not bother them much. They will go for star snowflake schema.
Okay.
Okay,
Yep.
so it all comes based on your data, what kind of data you are going to receive, how do you want to store it into your data warehouse, right? So until this point of time, our work is not started, right? This decision is all taken by your probably architects, information architects, business users as in clients who know technical as well as the business requirement, right? They will set all together. If any project is starting from the scratch, what will happen first? They directly won't hire developers. First they will hire their information architect, database architect, right? They will be having some kind of business BAs rise business they will be having their BAs to analyze the requirement. They will analyze the requirement. They will discuss what kind of data warehouse technique we can follow, whether it needs a data warehouse or it needs a database. If suppose there is a small application which is not having that much of data, right? So they will not go for a big data warehouse. They will go for a small database or small disk where they can store their data, right? Which is not rightly the case, because whenever we are starting a project, a big project, they will be having huge amount of data if they are going to Abinitio especially, right? So they will all take these decisions. What kind of tool do they want to need? If they want Abinitio, what kind of Abinitio tool do they want? Do they want GD additional to GD? If they want some scheduling tools from Abinitio, or they would be using different scheduling tool like Tivoli or Control M or Control Center, right? So all these decisions will be taken up before starting the project. So project will be started at their end, but not as perspective of a developer, right? Developer comes later into picture when they have converted their business requirement to technical requirement. When they are able to start the work, they will hire developers. They will start their work slowly and steadily, and also they would start gathering further requirements which needs to be implemented in a project. So whenever a project is starting, it's not going to happen that the project will complete into 5 or 6 months, right? So if you are working with any, suppose banking clients, so banking projects are running for years into a company, right? Because they will be constantly getting the data, they will be constantly upgrading their systems. So now suppose there was a bank, initially they, when data warehouse was into picture, but this big data was not into picture, what they used to do, they used to have their databases installed into different data warehouse servers, into different data servers, right? They had to manually install this databases. Later Hadoop came. What Hadoop changes? It says that you do not have to maintain this complete set of disk altogether by yourself. Create a cluster, we'll manage the cluster. You will be having one name node and different data nodes, right? So they came up with distributed processing, all that stuff. So what banks did, they moved from traditional data warehouse, traditional database to Hadoop file systems, right? Now later, after working on Hadoop for 5-7 years, now cloud storage came. So what they will do, they will move their data from Hadoop to cloud, right? But all the process that we are transforming, so they are just migrating their data to different storage techniques. All the processing that we are doing, it is still happening the same. So your data is not changing, your process is not changing. What is just changing? Your data sources and data targets, right? So whenever we are changing our sources or targets, compatible to that, we'll have to have some plugins into Abinitio, and we'll have to change some bit of code, okay, so that we can make it compatible with those kind of data sources or data targets, right? So the project is constantly running, right? There is no change. So the project has not ended, right? So in this form, this techniques that we are using, this structure is not going to change. This structure I'll take it as is to Hadoop. This structure I'll take as is to cloud. Okay, what as an ETL developer we do, right? So we are not yet going to Abinitio, but suppose a common ETL developer. What is ETL process? ETL process is extract, transform, and load. Okay, now what extraction means? Extraction means reading data from your source, right? So if you have a flat file, you can directly read. If you have a database, you will have to use some database components into Abinitio. Into say Informatica, you will be using some database connectivity components, right? You will be connecting to database, you will be extracting data from there. Suppose if you are reading from Hadoop file system, you will have to connect to Hadoop file system and extract data from there. If you're reading data from your web services or geographical files, you will have to connect to that web service and then get the information, right? So extraction is the process of reading data from your source, right? Since there could be different sources, somewhere we'll have to fire some queries, somewhere we can directly read. That's why we call it is extracting. Okay, so extraction is the process to read your data. Load is the process to load your data into your target system. Again, it could be a flat file, it could be XML file, it could be Excel file, it could be a web service, a database, a data warehouse, Hadoop system, right? Any kind of. So we are having different sources, different targets. It's not that we are reading from a single source and loading to a single target, right? And since there are different sources, different targets, we'll have to transform our data according to our target system, right? So the main picture as an ETL developer comes into this transformation phase where we are changing our data as per our user, target user or target system, right? So here, if you are using Abinitio, you will have to use Abinitio components, you will have to use Abinitio codes. If you are using Informatica, then you will have to write your code into Informatica syntaxes. If you are using any Hadoop, say Spark or Scala, you will have to write code into that particular tag, right? And once we load the data, there is an additional step which we always not cover up or we always miss is the process. So once we have loaded data into our target system, right, the work is not finished. As a developer, your work is finished, but what needs to be done on that data? We have to some business decisions, so we'll have to process that data. We'll have to derive some reports or some decisions based on the knowledge that we have created and stored into our data warehouse, right? So that those data mining, data analytical application, data science application, we are calling it as a process or process step. So it becomes ETLP. If you are working in a project where you are generating reports as well, that will become as an ETLP, right? Most of the projects are ETL, but you should be aware of this term, okay, and what is done on your data further, right? So this is a definition like of all the steps. Okay, extraction is clear, we are getting data from source. Load is clear, we are providing data to our target system. Transformation, once we have extracted data from source, we'll apply some business rules, right? It is a possibility that you want to filter out some data from your source. You want to summarize, like summarize in case of like if you want per month sales for a particular month, how much amount of sales is done, how many units of a particular items have been sold, from which store it has been sold, right? So you will have to group your data, you will have to aggregate it, right? So if I'm saying amount per month, so what you will have to do, you will have to calculate and sum up all the amounts that you are receiving into a particular month. So we are calling it as summarizing or aggregating. Merging, if you want to merge 2 or 3 files, right? If you want to transpose your data or any kind of stuff that changes your data, all that process we call as it as transform. Okay, and after what do we do into this transform? We do it based on a business rules which are defined as per my target systems. What kind of data my target system wants, like likewise I'll change my data. Okay, ETL tools, different ETL tools are available: Abinitio, Informatica, Data Stage. Into Hadoop you will be having some, into Google Cloud you will be having some, into AWS you will be having some, right? So all these ETL tools are available into market. Then we are going to Abinitio. Why? Because Abinitio is easy to use. So if you have created a graph, if you are showing that graph to any of the user, if you have written your code with all the comments, right, Abinitio always shows you that particular code in graphical format that we call as it as a graph, right? It is easy to understand for any user, right? It provides us parallel processing, distributed data processing, right? It provides us connectivity to heterogeneous sources and targets. So there is hardly some source or target system where we do not have connectivity with Abinitio. May it be cloud, may it be Hadoop system, may it be a Teradata, Oracle, different kind of heterogeneous DBMSs, right? So for database management system also we have different DBMS. Some uses Oracle, some uses Teradata, some uses Access, MS Access, some uses, you know, Netezza. So there are different systems. So it has connectivity to all, right? It for if you are having huge data, if you are working on a data warehousing project, Abinitio provide different kind of techniques so that you can faster process your data faster, uh, other than other ETL tools. Okay, Abinitio provides a faster processing. Now again, Abinitio has come up with some tools like data quality tools. They are having Acquire It as a tool. They are having Data Profiler as a tool. So it's not only GD, right? So if some business user wants to use Abinitio, who has not much knowledge into technical domain, and if he uses Express-it, he can check whether a particular mapping that they want to do, it is possible into Abinitio or not. So they will not have to spend more time or more money. They will have to, they will not have to take a developer to check whether it is possible or not. They themselves can create a mapping. They can check whether it is possible into Abinitio or ETL tool or not, right? So that saves them cost somewhere for hiring developers if it is not possible. What will happen if something is not possible, and if you have hired a team of 10 people, right? You will be giving salaries to them. You will have to start onboarding activities for them, which will again cost them time and money, right? So they can save all this kind of time and money stuff using that particular tool. If they want to improve data quality, if they want to check data quality, they can use data quality tool. They can use data profiler where they can profile their data and see like what kind of unique values they are getting into a particular column, what are the duplicate values that they are getting into a particular column, right? All that kind of analytics can also be done using Abinitio, right? So that's why it is more famous among business users, right? So if we'll see major clients like banking clients, telecom clients, insurance clients, retail clients, here and there, everyone will be using Abinitio, right? It is not required that all clients should use Abinitio only. So whenever a client is going to Abinitio, you won't find much things on to web on Abinitio, right? So whenever a client is going to Abinitio, Abinitio Corporation will evaluate whether Abinitio is really required or not for that particular client. Or if Abinitio is required, what kind of tools is required, right? And then they will be giving that product only to that particular client. So they are not giving tools to every client as well, right? So it could be their business strategy that they want to keep it as a secret, right? And they do not want to give it to every client as an open source, or even if it is a license. The license cost is although high for Ab initio, but again, major clients are going to Ab initio, right? Because of these kinds of different techniques that Ab initio provides. Okay, that we'll discuss further in our tomorrow's class. We'll also discuss Ab initio architecture, Ab initio concept, like what are the most frequently used terms and techniques into Ab initio, so that whenever we are using these terms, you should not get confused. Okay, we'll see our Ab initio architecture in detail tomorrow. Okay, so we'll be going through this complete stuff tomorrow. So for first class, I just wanted to make you aware about this data warehouse and what ETL processor. I hope it is clear. I mean, you won't get confused whenever we are using these terms: extract, transform, load, fact, dimension, schema, data warehouse, subject, right? Integration. So you are aware of these terms now, right? This is all a theoretical concept. I'll send you PDFs where you can read it. I'll send you this PDF also. where it is all defined regarding Abinitio, so no need to create any kind of notes. You will be having already created notes. Okay, for data warehousing, I'll send you different PDFs. So if you want to read data warehouse in details, you can refer those PDFs. Okay, any question from today's class? Anyone?